All right, welcome to GBank's Mathematics, and today we are looking at the WASI PC2, which is the second series in DEC 2025 elective maths that was written, question number 9A. All right, so let's see. They're saying if alpha and beta are the roots of 5x squared minus 9x minus 4 equals 0, find the equation whose roots are alpha squared minus 3 and beta squared minus 3. So quickly, we know that the equation has been given as 5x squared minus 9x minus 4 equals 0. We can rewrite this equation in the general form of a quadratic, all right? Meaning we are going to make the coefficient of x squared to be equal to positive 1. To do that, we are going to divide through with the coefficient of x squared. So dividing through this whole thing with 5 here, 5, 5, and then 5, we're going to have x squared minus 9 out of 5 x, then minus 4 out of 5 equals 0. Now comparing what we have here to the general equation, which is x squared minus sum of roots x, then plus product of roots equals 0. You know, to form a quadratic equation, you can use this step. So comparing these two equations, we can say that the sum of roots in this case where they are saying alpha and beta are the roots, so the sum of roots, which is alpha plus beta, you know sum is plus, right? Positive, plus. So alpha plus beta can be given as, comparing the two equations, this gives us 9 out of 5. Comparing the two, we have x squared, we have minus, and then sum of roots x. When you compare this, okay, product of roots, let me put it here. The product of roots is also going to be, we know that as when we say product, we are looking at alpha multiplying what? Beta, if they are saying alpha and beta are the roots, right? So the product, comparing this gives us a product to be negative 4 out of 5. So we have this first two. Now they are saying we should find the equation whose roots are alpha squared minus 3 and beta squared minus 3. So we have to find the sum of the new roots. Sum of the new roots, right? Some of the new roots that we have alpha squared minus 3 plus we have beta squared minus 3. Since we are looking at sum, it means we're going to add them. So adding this gives me alpha squared plus beta squared, then minus 6. Alpha squared plus beta squared minus 6. And we know that alpha squared plus beta squared is an identity on its own, right, when it comes to symmetric properties. So we are going to write the expansion for alpha squared plus beta squared, and that is alpha plus beta all squared minus 2 alpha beta. That's the expansion for alpha squared plus beta squared. Then we have our negative 6 here. So from this point, we can do some substitution. We can see alpha plus beta all squared here, and we know what alpha plus beta is from the roots given. So alpha plus beta is 9 out of 5. So we have 9 out of 5 all squared minus 2 multiplying alpha beta is a product, which is negative 4 out of 5. So negative 4 out of 5, then minus 6. So we enter the whole thing in the calculator, right? So we have 9 out of 5 all squared minus 2 multiplying negative 4 out of 5 and then minus 6. And this gives us negative 29 out of 25 as the sum of the new roots. We do the same thing for the product. the product of the new roots, we're going to have alpha squared minus 3 multiplying beta squared minus 3. All right, so let's see how this will turn out to be. If we expand this, we have alpha squared beta squared, then we have negative 3 alpha squared, negative 3 beta squared, and then positive 9 when we expand the two brackets. Okay, so here using powers of numbers, we can write that as alpha beta all squared, because alpha squared beta squared can be written as alpha beta all squared. Then here, these two, which is negative 3 alpha squared minus 3 beta squared, we can simplify it by factorizing negative 3 out. So negative 3 out, I'm going to have alpha squared, and then since I've taken negative 3 out, I'm going to have plus beta squared here. And then I have plus 9. All right, so we have alpha squared plus beta in this bracket. We can therefore expand that quickly and then have alpha beta all squared minus 3. Then I have a bigger bracket because alpha squared plus beta squared is an identity on its own. And that gives me alpha plus beta all squared minus 2 alpha beta. All right, then I have my positive 9. So let's quickly do our substitution here. Alpha beta has been given as a product of roots, and that's negative 4 out of 5 all squared. Then I have negative 3 multiplying, this is my bigger bracket, alpha plus beta all squared. So alpha plus beta is 9 out of 5 all squared. Then minus 2 alpha beta is still product, which is negative 4 out of 5. Then I close my bracket, then plus 9. So we can do what we have outside here and then do what we have inside there. We can put everything together. All right, so putting everything together here, we're going to have negative 122 out of 25 as the simplification for the whole thing here. So to find the new equation can be given as x squared minus, into brackets, sum of roots. Because we are looking for the new equation, we are going to use the new roots, right? X squared minus sum of roots x, then plus product of roots equals 0. So let's do our substitution. I have x squared minus sum of roots is negative 29 out of 25 x, then plus my product of roots gives me negative 122 out of 25, and this is equal to 0. So expanding all the brackets gives me x squared plus 29 out of 25 x, and then minus 122 out of 25 equals 0. And you know we can't leave our answer in improper fraction. Okay, so since we can't leave our answer in improper fraction, we multiply through with the LCM. The LCM is 25. So this gives us 25x squared plus 29x minus 122 equals 0. So this was the answer that was expected from students in this question. Thank you so much for watching. Please go to the next video for question number 9B in the playlist. Thank you so much. Remember to like, follow, and share for more videos. Bye-bye.